Okay, so today's videos, we're going to do a 3 video series here. We're going to do this warm up first. Then we'll do a video where we start to graph the graphs of sine and cosine. And then we're going to put it all together with some of the different parts of the graph for our third video. So let's talk about this first one. Um, Hopefully you've had a chance to look over the questions here. Basically, we are going to use this little acronym that I gave you guys last time, the ASTC. And if you remember, that basically tells you which trig function is going to be positive in what quadrant. Okay, that's important because in this first one here, what they're looking for is to state the quadrant in which theta lies. So they're telling you that the tangent here is less than 0. Well, if you look at your little ASTC thing, tangent is only going to be positive. Remember, everything is positive up here. But tangent is only going to be positive in the third quadrant other than the first quadrant, which means that if tangent is less than 0, it is negative in this one and this one. So we're talking about quadrants 2 and 4. But then it says also, it says, and the sign has to be negative. Well, sine is, again, everything is positive in the first quadrant, but then sine is also positive up here in the second quadrant. So when sine is going to be negative, sine is going to be negative down here in the third and in the fourth quadrant. So that's 3 and 4. In order for both of these things to occur, because it says that tangent has to be less than 0 and sine has to be less than 0, we're looking for the overlap. Well, both of these are going to overlap in quadrant 4. So the answer to that one is quadrant 4. Okay, if we look at number 2, again, we're going to use, I'm going to erase all these little dots that I've put up here. But we're going to use that ASTC thing for just about every single one of these things. So in number 2, it says that cosine has to be positive. Again, remember, everything is positive in quadrant 1. Oops, everything is positive in quadrant 1. And cosine is also positive in quadrant 4, according to our ASTC. So 1 and 4 are for cosine being positive. And then it says that pi is less than or equal to theta, which is less than or equal to 2 pi. This is basically just telling you, if you think about your unit circle, where the quadrants are that theta is going to be in. Well, pi is way off to the left and 2 pi is way off to the right. So if you think about your unit circle, like this, something like that, pi is over here, 2 pi is over here. If I go, remember, everything goes counterclockwise. So if I start at pi, go counterclockwise in that direction, I've covered quadrants 3 and 4. So where's that overlap? That is also quadrant 4, because that's where they overlap. All right, let's move through the rest of these. If sine is less than 0, again, sine less than 0, that's going to be in quadrants 3 and 4, because sine is positive in 1 and 2. And then theta being in between 0 and pi, well, that's the top half of the circle, so that's going to be quadrants 1 and 2. Well, what's the overlap between 3 and 4 and 1 and 2? Well, you should hopefully realize that there isn't any. So this one actually has none. That is not possible. All right, and number 4, sine is positive. Sine is greater than 0, so that's quadrants 1 and 2, according to our ASTC. And then pi halves to 3 pi halves. Well, pi halves is way at the top. 3 pi halves is way at the bottom. So that's going to go through quadrants 2 and 3 to get there. And then the overlap here is quadrant 2. Okay, number 5, cosine is less than 0. Well, cosine is positive in 4. Everything's positive in 1. So cosine is going to be less than 0 in quadrants 2 and 3. And then it says that theta is going to be in between pi and 2 pi. Well, that's the bottom part of the circle. Again, that's the same thing that we just did up here. So between pi and 2 pi is 3 and 4. So the overlap is 3. All right, number 6, tangent is greater than 0. Tangent is going to be greater than 0 in quadrant 1 because everything is positive there. And according to ASTC, it's also greater than 0 or positive in quadrant 3. And then pi halves to 3 pi halves, just like the one right above it on number 4, is positive, is going to be in 2 and 3. So the overlap here is quadrant 3. So really all that is determining what quadrant you're going to be in based upon a couple of different pieces of information. They're either going to tell you where the trig function is positive or negative, or they're going to tell you what possible quadrants you could lie in by telling you where theta could be. And then you have to determine the actual overlap there. All right, moving on to number 7 and 8. Okay. So we are actually going to be finding the other 2 of the trig functions given one of them. And if you remember, basically this is going to be where you have to create a right triangle. So we will create a right triangle to figure these things out. Theta we'll put there. Remember that cosine, by using SOHCAHTOA, is adjacent over opposite. The adjacent side then would be the numerator. The opposite side would be, wow, did I say adjacent over opposite? It's adjacent over hypotenuse. I don't think I said that right. The adjacent side is 4. That's here. The hypotenuse is 5. That's here. Okay, we'll deal with the fact that there's a negative sign in just a minute. It does tell us that this lies in quadrant 3. So we know if sine or tangent are going to be positive or negative, again, based upon ASTC. We are going to need to find the missing side. Remember, to find the missing side, you're going to use Pythagorean theorem. And that says that 4 squared plus whatever this is over here, we'll call it b for now, b squared has to equal c squared, which is 5 squared. So 4 squared is 16, b squared is just b squared, 5 squared is 25. In order to solve that, we'll subtract 16 on both sides, which is going to give us b squared. See, 25 minus 16 is 9. And in order to find b, you're going to take the square root of both sides, making b equal to 3. So b equals 3 over here. So my missing side was the length of 3. And we need that because sine, according to SOHCAHTOA, is opposite over hypotenuse, which is going to be 3 over 5. 3 over 5. And it is in quadrant 3. Sine is not positive in quadrant 3, so we need to make it negative. Tangent, again using SOHCAHTOA, is opposite over adjacent. So that's going to be 3 over 4. And tangent is positive in quadrant 3, so we leave it just like it is. Okay, let's try number 8. So number 8, once again, we'll draw ourselves a nice little right triangle. Put theta in here. And this time they tell us the sine is negative 12 over 13. And they tell us that cosine is less than 0. Okay, well that puts us in a couple of different places. So we need to figure out the quadrant here because they don't just flat out tell us what quadrant it's in. If cosine is less than 0, according to ASTC, that means it's got to be in either 2 or 3 because cosine is positive in 1 and 4. But it also tells us here over here that the sine is negative, and that's because of the sign being the negative sign out in front of 12 and 13. And if sine is negative, that means it's got to be in quadrants 2 or 3. I'm sorry, it's got to be in quadrants 3 or 4, excuse me. Well, where's the overlap? Well, that's quadrant 3. So we know that this is going to be in quadrant 3 because that's where the overlap is. Okay, and that's important only as far as the positive and negative signs are concerned. Let's go back to our triangle. Sine is opposite over hypotenuse, so the opposite side is here, that's 12. The hypotenuse is here, that's 13. Okay, once again, if you use Pythagorean theorem, you're going to get, let's see, 12 squared plus b squared equals 13 squared. Well, 12 squared is 144. B squared is still just b squared, and 13 squared is 169. Subtracting 144 on both sides, you get that b squared equals 25. So then taking the square root of both sides, b is going to be 5. So our missing side there was 5. So cosine is adjacent over hypotenuse. Adjacent is 5, hypotenuse is 13, so that'll be 5 over 13. This is going to be in quadrant 3. Cosine is negative there, so we'll put a negative out in front of our fraction. Okay, tangent is going to be opposite over adjacent, which is 12 over 5. And this is third quadrant. Tangent is positive, so we don't need any negative signs. It is good to go as it is. All right, a couple more. All right, number 9 says that tangent is undefined. We'll worry about the quadrants in a second. Tangent is only going to be undefined because remember that tangent is y over x. For something to be undefined, it means you're dividing by 0. So that means x has to be 0. So if you go to your unit circle and figure out where the x value is 0, that only occurs in 2 places. Okay, the x value is going to be 0 at either pi over 2 or 3 pi over 2. And if you look, this wants our angle to be in between pi and 2 pi. Well, the one of those that occurs between pi and 2 pi is on the bottom part of the circle, so that is going to be at 3 pi over 2. Didn't absolutely have to have that information, but it is good to know that that's where it is. But anyway, you need to find 3 pi over 2. Well, yeah, actually, you did need that information because at 3 pi over 2, we're looking for the sine and cosine. Well, these are actually now unit circle values. So this is not something where you have to draw a triangle because this is on the unit circle. So if you remember, sine goes with y and cosine goes with x. We're just looking at the x and the y values at 3 pi over 2, and that's our answer. So at 3 pi over 2, the sine value or the y value is -1. And at 3 pi over 2, the cosine or the x value is 0. And that one's done. No need for a triangle. All right, last one, number 10. Those numbers are kind of big. We'll deal with it. Probably going to need to use a calculator for this one for sure. All right, let's see. Cosine is negative. Cosine is adjacent over hypotenuse. So adjacent is 11, hypotenuse is 61. And it tells us that this has to be in between 0 and pi, which is quadrants 1 or 2. But because cosine is negative, it has to be quadrant 2 since everything is positive in quadrant 1. So this is going to be a Q2 problem. We are going to need to use Pythagorean theorem to find our missing sides. So that's going to be 11 squared plus b squared equals 61 squared. I will be the first to admit I do not know what 61 squared is off the top of my head. I do know 11 squared is 121. We're going to put 61 squared into a calculator and see what that gives us. So 61 squared is 3,721. 3,721. And then we'll take away 121 from both sides. So b squared is going to be 3,600. Now, ironically, I do know what that one is. This actually works out very nicely. The square root of b squared is b. The square root of 3,600 is 60. So that's our missing side. Now we can very easily do the sine and the tangent. Sine is opposite over hypotenuse, so that is 60 over 61. In quadrant 2, sine is positive, so we leave it like that. Tangent is opposite over adjacent, 60 over 11. And in quadrant 2, tangent is not positive because tangent is positive in third, so we'll put our negative sign out front. And we are done with the drill. All right, we will come back with a second and third video to finish off the lesson.